Now, a graph is said to be a tree if it is connected and has no cycles. Means that, say, in this example, say there are four vertices A, B, C, D. No doubt it is a graph. But if you say there is a cycle, so there is a edge between A to B, B to C, C to D, and again D to E. So we say that there is a cycle. So this graph is not a tree. Okay. So what is the condition a graph to be a tree? It should be connected and there should be no cycles. Say for example, this graph G1 is, we can say it as a tree. Okay. It has two vertices, both are connected. Okay, and there is no cycle. And even this G2 is a tree because it has three vertices, all vertices are connected and it has no cycle. If you observe third example, it is also having no cycle. A tree as a rooted tree, if it contains unique vertex called as root whose in degree is equal to 0.
That your screen is off.
Sorry, let me present it now. Well, now let us discuss about rooted trees. A tree T is called as rooted tree. First condition is it should be directed graph. Okay, and T contains unique vertex called as root whose in degree is equal to 0. It means that, see, this node or vertex, say it is A. Now we assume that its direction is like this. So out degree for this A is 2, but in degree is equal to 0. There are no edges which are coming towards A. So we say such node as root node. Okay. Then second is the in degree of all other vertices of T is 1. So internal vertices apart from this root, say if it is a root, apart from this root, you consider any number of levels, but in degree of every vertex must be 1. Then we say it as a tree, a rooted tree. Okay. Then Mri tree. If every internal vertex is of out degree or it has out degree less than or equal to m, then we say such graph or such tree as Mri tree. Say for example, if I take m is equal to 3 here, then this every internal, this is called as internal node or internal vertex. It is called as, say, root. Again, this is internal node, and so on. So all these internal nodes must be having out degree maximum 3, not more than 3. ಓ ಆನಂದ್ ಸರ್ ಹಿಂಗ್ಯಾಕೆ ಮಾಡ್ತೀರಿ? ಎಷ್ಟು ಸಲ ಹೇಳಿ ಈಗ ನಾ ಸಿಟಿಗೆ ಬಂದಾಗ ಸುಮ್ ಕೊಡೋರ ಹೆಂಗೇನು? ಕ್ಲಾಸ್ ಹೇಳತ್ತೀನಿ ರೀ, ಹೇಳತ್ತೀನಲ್ಲ 4 ದಿನದಿಂದ ಸಮಾಧಾನದಲ್ಲಿ ಹೇಳಕತ್ತೀನಲ್ಲ, ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಅನ್ನೋದು ಇರ್ತದ ಇಲ್ಲ? ಹೇಳಿ ಕೇಳಂಗಿಲ್ಲ ಹೇಳಿ. Sorry for disturbance. Now Mri tree, I was discussing about Mri tree. Now let us see. All internals node are having out degree maximum 3, less than 3. So less than or equal to 3 when m is equal to 3. So such trees are called as Mri tree. Now when we go for complete Mri tree, it means that all internal nodes must be having out degree exactly m. So if I take m is equal to 3 here, then all internal nodes must be having out degree 3. So like this. Again, if there are if there is out degree, then there must be 3. 1 2 3, 1 2 3, and so on. So for all internal nodes there must be outer degree as 3, exact 3. So such trees are called as complete MRA tree. Then binary tree, here m is equal to 2. So binary tree means every internal node must be having less than or equal to 2 outer degree or 2 children. We say outer degree as children here because, say, if this is the internal node, P is the internal node, then its outer degree is 2. It means that it has 2 children. So it must be having less than or equal to 2 children, then such tree is called as binary tree. Then in case of complete binary tree, every internal node must be having exactly 2 children. Like if I have this as root node, then every internal node must be having exactly 2 children. Okay. Now balanced tree. Now, to understand balanced tree, first we need to understand about height h of the tree. Now let us say h is the largest level number achieved by a leaf. So in this case, say this is level number 1 and this is level number 2. Okay. Now we say that height of this tree is equal to 2. Okay. Now a tree of height h is said to be balanced if level number of every leaf is h or h minus 1. Now leaf is nothing but these vertices, say these, whose outer degree is equal to 0. So a leaf or node with outer degree equal to 0 is called as leaf. Now every leaf must be at level h or h minus 1. Then we say such tree as balanced tree. Say this is. Now can you tell me whether this is a balanced tree? Can someone reply whether it is balanced tree? No, it is not balanced tree. Let us see why it is not. So this is level number 1 and level number 2, level number 3. Okay. So what is the height of this tree? It is 3. H is equal to 3. So every leaf must be having, I mean, or it should be at the level H or H minus 1. It means that it should be at level 3 or it should be at level 2. But if you consider this leaf, its level is 1. So therefore this tree is not a balanced tree. If I draw one more level here, then it will be balanced tree because all these leaves are having levels either h or h minus 1. Okay. And similarly, full binary tree, it means every leaf node or every internal node must be having exactly 2 children. Okay. Now there are some standard results to be remembered. For complete MRA tree of order n means number of vertices in that tree. With p leaves, we have p leaves and q internal nodes. Okay. In such, for such tree, n is equal to mq plus 1 is equal to mp plus 1 or divided by m minus 1. These are the standard rules. They may ask you, find a number of vertices in a tree given that 10 number of leaves and 20 internal nodes. In such case, you will be able to find by using this formula. Similarly, p is equal to m plus 1, sorry, m minus 1 into q plus 1 or m minus 1 into n plus 1. Similarly, there is a formula for q. Now, for complete binary tree, that is for m is equal to 2, the above results become n is equal to 2q plus 1, p is equal to q plus 1, q is equal to 1 by 2 into n minus 1. Now, you may use any of these formulae according to your requirement. Thank you.